Alright, so we're talking about inverse functions. If I give you a function, we call it f. If f is one-to-one function with a domain and range, then if I take the inverse of the function, we call the inverse of the function here. Everyone say inverse function.
Inverse function.
Now pay attention. This is not an exponent. This is not f to the negative 1. So don't say f to the negative 1. We say what, class?
Inverse function.
We say inverse function. Well, what do you notice about the inverse function? It still has a domain and range. And what happens is if you see this negative 1 here, it's an inverse function. And what it's telling you to do is switch. Everyone say switch. Do you see the switching there? The A and the B have switched its places. Do you guys see that? Yeah. All right, here's my practical example. If I take the order pair -3, 40. -3, we're not using the graph, we're just kind of using it by quadrant, so don't use the scale. So -3 left, and then up here 40. Is that okay? Now let's just say I switch the places of x and y. What would the order pair read? 40, -3. Something over here, right? Would you agree? How does it go from over there to over there? I switch the x and the y, but I'm basically going over this line. Class, what's the name of this basic function?
Linear.
That's a linear. And very specifically, this is y equals x. Okay? And you're noticing basically what's happening is you're going over this reflection line, or this identity. We've actually talked about that, right? It's called the identity. So this is an example of an inverse function.